Hello, team. Today's challenge is the Tic-Tac-Toe challenge, where we are given an array of arrays and we need to figure out who wins or if anybody wins. Maybe it's a tie, right? The challenge here is that we are working in a multi-dimensional array, so that kind of changes things a little bit. But ultimately, if we take a look at this, we only have so many solutions, right? No, not so many solutions in terms of code, but only so many solutions in terms of tic-tac-toe, X's and O's. So we have this grid. It's always 3 by 3, at least the way that I've always played it. And we have 8 possible solutions. We can go across 3 times, down 3 times, and diagonal twice. Okay. So we could do this programmatically and try to figure those out, or we could just code it out, right? It's only 8. So to save us a little bit of time, save you from having to watch me do this, I've already done that, okay? I've taken this grid and made it an array of solutions, okay? And they line up exactly. Again, that's why I put 0 here, because it's 0 based, okay? But here's the challenge. With this, I've made the assumption that we are getting a single array, a flat array of numbers. And we aren't. We're getting a multi-dimensional array of numbers, of markers, sorry, not numbers. So we need to compress it down. We need to flatten it to get started, okay? And that works like this. I'm going to create a new variable. Let's call it, you know what? I think we can actually just do board, okay? Let's actually just go board.flat. Boom, okay? Flat does take an optional argument. So if you had a lot of stuff and you wanted to compress it down, right? Just a huge number of arrays inside of arrays inside of arrays, you could use this to flatten that down to a single array of things. Here, it defaults to 1, which is all we really need, okay? So with that in mind, we can do a loop, okay? And with this, we don't care about the indexes or anything special. So we can use that newer style of loop where we have let solution of solutions, okay? And from there, we do stuff inside of here, okay? The first thing I want to do is break out those options, those positions from this set, okay? So right here, we can destructure a little bit, A, B, C. You can name those as first, middle, last, right? Lots of options there. And of course, we have solution. Brilliant. Now we can use those down here where we do an if statement, okay? And that if statement is pretty simple, actually, okay? We have not solution, but board A equal to board, come on, spell it right, board B, and taking all this, putting it right down here, getting rid of this and, board A equals board C. Oops, C, okay? That should be all we need for this. We can actually go down and complete the if statement, just like this. If that's what we got, we are going to return early. We're going to cancel out. We've already found the winner. We don't need to go any further, okay? And it looks like this. We have that dollar placement and wins, not wins, but wins, okay? Board A is the winner, so we can actually just grab that right there. Brilliant, okay? If nobody wins, then we return draw, just like this. And that should do it, okay? So right here, what we did is, because we only have a fixed number of solutions in tic-tac-toe, we could build this. We could build this programmatically or find something to make it work. It would be really complicated, a whole lot of extra stuff. We don't need that, okay? There are only 8 possible ways to win at tic-tac-toe, so we just went and coded them, okay? Again, if we were doing something like Connect 4, right, then we'd need a different solution, obviously, because that can be anywhere. But for us, this works. And then we had to do a little bit of flattening, okay? And there's an interesting bit in here that I'll talk about in a second. So if we take that This was actually um, number 2. So if you're looking at test 2, right, I took that and I brought it over, okay? But we had to take this array of arrays and flatten it. And the reason that I'm bringing this in is because there's a funny little glitch in their test here where both win. But I guess the assumption is that O placed their marker first. A little bit somebody should have tested, right? Somebody, the test passes because we hit this line before we hit this line. But I mean, the way that they've given it to us is kind of interesting where that marker is in place. So a little curiosity, but we'll work with it, right? That's what we do. Anyway, we had to take that and flatten it out, and that's what dot flat does, okay? It absolutely does that. We can actually punch anything in here, right? Infinity is your friend if you have just a huge amount of nested arrays and you want to compress them down to a single thing. Infinity will do it, okay? But it defaults to 1, so we didn't need to do anything there, which took that to a single array, XOX, XOX, OOX. And then from there, we just tested, right? We tested against our solutions to see if the index lined up. There are places where if this actually isn't filled in, we might need to do something there, but for now this works, right? We might need a little extra bit inside of our conditional if this came to us different. Again, it works for today, and we kick it out the door, okay? We figure out what that marker is and return that marker wins. Brilliant. Otherwise, it's a draw. Did you find a different solution? I'm sure that there are plenty of others on this. I feel like the programmatic solution to get into this might be pretty interesting. So if you've done that, please share it. Might be pretty fun to look at. But for now, this is it. I hope that you do share those solutions, and I will see you in the next one.